All right. Hello, everybody. My name is Talia. I'm a senior developer advocate here at AWS Serverless. I work in AWS's Los Angeles office, and by office, I mean my living room in Los Angeles. This is my first reInvent ever. Is it anyone else's first reInvent? Yes. All right, raise your hand if it's more than 5. More than 6? More than 7? Do you want to come up and give this talk? All right, so a lot of people say that Christmas is the most wonderful time of the year, but let's face it, reInvent is the most wonderful time of the year. This is all anyone has been talking about for the past few months, and it's all culminating this week. So this talk is a deep dive into building Windows Vista applications in the cloud. I hope you're all in the right room because they just locked the doors, so buckle up. I'm just kidding. We're going to be talking about what's new in serverless today. My name's Talia, and my job is to build serverless things and teach the world about them. Before becoming a developer advocate, I was a test engineer. I did QA, I did automation, I did end-to-end testing, all the stuff that you developers hate doing, that was me. All right, so over the past year, we've released so many new things. There's been so much new stuff happening at AWS, and it can be so hard to keep up with the pace of everything. I know even myself as an AWS employee, I can get pretty confusing and pretty lost with everything coming out. So we do this talk so that you guys know everything that has come out. Well, not everything, but as much as we can get through. I'm going to talk about the key items of the past year and what you might have missed due to the fire hose of information that comes out of AWS. All right, so throughout this talk, I'm going to be coming back to 2 themes. Serverless development is getting easier and faster. So as I'm going through the new features today, look out for these 3 icons. The icon on the left indicates that this feature makes serverless development easier. On the right, this feature makes serverless development faster. And in the middle, this feature makes serverless development easier and faster. All right, so when we're talking about serverless, I want to focus really specifically on this idea of a serverless application that's focused around AWS Lambda. And for those of you who are new to this space, Lambda is a serverless compute service where you create your application code in what's called Lambda functions. In your Lambda functions, we support 6 main managed runtimes. These are runtimes where we help with the feeding, watering, patching of the runtimes, and we also update them occasionally. So these are Node, Python, Java, C#, Go, and Ruby. You can also bring in your own language into Lambda by using what's called a runtime API. Now, on either side of your Lambda function, you have your event source and your destination. Your event source is something that happens that triggers your Lambda function and makes it come to life. So this could be something like a payment process through a third party like Stripe. It could be an item dropped into a DynamoDB table. It could be an object put into an S3 bucket, just something that happens that wakes up Lambda and says, hey, go do this thing. And then you have the destination, which is things that your Lambda function can talk to. So this is databases and data stores and object stores like S3. So you have this idea of a serverless application that is centered around Lambda. So in this talk, I'm going to be focusing primarily on what's new with just a few serverless services. Unfortunately, we don't have time to go through every single serverless service. But the services we are going to cover today are Lambda, API Gateway, Step Functions, EventBridge, and the serverless application model. These are just some of the most commonly used serverless services. And I think that when people think about serverless, these are the services that you usually think about. But don't forget, there are other services that we won't have time to touch on today. So Amazon SNS, which is a pub sub-service you can use to fan out messages. SQS is a serverless queuing service that's really good for decoupling and scaling microservices. We have AppSync, which is good for building GraphQL APIs. We have S3, which is an object storage service that integrates really nicely with Lambda. And DynamoDB, which is our NoSQL database that's good for massive, massive, massive scale. All right, so we have to start with Lambda. I feel like if we started a serverless talk and we didn't start with Lambda, there would be fires and riots and chaos. So Lambda is our serverless compute service. It's at the center of a lot of serverless technologies, and you don't have to worry about provisioning or managing servers. There are trillions of Lambda invokes per month, and hundreds and thousands of our customers are using Lambda. All right, so the first release I'm going to talk about is the launch of Graviton 2. Now, just a caveat, I was told this morning that Graviton 3 came out. So we're just going to pretend that none of you went to this morning's talk. So with the Graviton 2 release, you can target functions deployed with a container image or a zip file to run on either x86 or ARM-based processors. So if you're trying to decide if you should use Graviton, you can create two versions of a function, one with x86 and one with Graviton, and then you can distribute traffic to both and measure your metrics and logs with CloudWatch. OK, the next feature we're going to talk about is cross-account ECR images. So Lambda now allows you to create or update your Lambda functions with container images that are in a different account than that of your Lambda function. So previously, you couldn't access container images that were stored in other accounts. You had to copy that image to the same account as your Lambda function. What's great about this is that it avoids the "it works on my machine" shenanigans, right? If you can pull the same container image and use the same data in more than one place, you're ensuring consistency between environments and consistency between accounts. It also gives you one source of truth for your deployment pipeline, so you don't have to copy images in more than one place. All right, next up is event filtering. This is something we literally just launched, I think. What day is it today? Tuesday? I think we launched this Friday of last week or Thursday of last week, but it was like right before reInvent. Did they talk about event filtering this morning? I got one to myself? Great. OK, so previously, a Lambda function would get invoked based on all the events that were put onto a stream from DynamoDB, Kinesis, or SQS. Now, when you set up your event source mapping, you specify exactly which type of event you're interested in. So this could be like an attribute. It could be like a specific part of an event that you're interested in. Basically, you're saying, I only want this Lambda function to be invoked if XYZ is true. Like, only get invoked, only wake up if the specific thing in this event is true. This is going to cause a dramatic reduction in the number of invocations of your Lambda functions, and you don't have to filter. You don't have to have filtering logic in your Lambda function. So to set up event filtering from the console, first you're going to choose a trigger for your Lambda function. The Lambda service will then filter the messages that it receives from the event source, and then it's going to batch them up and send them as the payload for the function invocation. Oh my God, that's supposed to be an emoji. Thanks, Amazon. All right, so this is an example of event filtering. Sorry, guys, I've been talking all day. All right, so I want to look at an example with a Peloton race. So let's say for this Peloton race, you have a 10-minute race, and that 10-minute race translates to 600 seconds. At the end of the race, I want to know the final ranking of how I did compared to everyone else. So let's say you have a ton of users, and at every second of the race, you have a ranking, and everyone else has a ranking. But during the ride, all of these events from everyone are being put into a stream and being sent to Lambda, right? So at second 30, I could be ranked 5, and at second 31, I could be ranked 6. So like at every second, I could have a different ranking. What's going to happen is during the ride, all of these events are being put onto a stream, sent to Lambda, but Lambda is coming back and asking, is this event the final event? Nope, so I'm not going to do anything. The next second, a bunch of other events come in. Is this the final event? Nope, so I'm not going to do anything. Once Lambda gets the final event, then it's going to go and do whatever it needs to do. It'll publish that ranking. It'll go talk to whatever destination it needs. But this concept makes serverless development easier because you can specify exactly what you want your Lambda function to respond to. And it makes it faster because your Lambda function is only going to be invoked when you need it to be. All right, now let's talk about what's new with API Gateway. API Gateway is a serverless API service. It makes it much easier to create, publish, maintain, monitor, feed, water, secure your APIs at any scale. The first thing we did for API Gateway was we extended mutual TLS support to support our third parties. So now you can import a third-party certificate, such as VeriSign or DigiCert, and bind it to your custom domain name for a mutual TLS-enabled API. So previously, you could only use a domain name using a certificate generated from ACM and Amazon Certificate Manager without any third parties, but now you can use third parties. API Gateway also has a new integration for step functions. Step functions can now invoke an API Gateway endpoint. And when you do this, you'll have a new resource type, and that's shown here. And it can be used with both standard and express workflows. This allows customers to call API Gateway REST APIs and HTTP APIs directly from a step functions workflow. Basically, what we did is we took the error handling of step functions and combined it with the authentication and throttling power of API Gateway. All right, next up is step functions. Step functions is a low-code workflow service used to orchestrate AWS services and build serverless applications. All right, this is my favorite thing that we've released in the past year. Don't tell anybody. The Step Functions Workflow Studio is a low-code visual tool for building step functions workflows in AWS. So when you build a serverless application, a lot of times you start with a Lambda function, but there aren't many applications that are composed of just one Lambda function, like just one component, right? Many times there are more than one Lambda function, and many times those Lambda functions talk to each other. It's also common to have databases in your serverless application, as well as queues. Some Lambda functions even talk to servers. So this is kind of what like a modern serverless application might look like. With the Visual Workflow Studio, this on the left becomes this on the right. So all of that complexity and all of the talking to different services and all of the connecting the dots, that all happens for you with the Workflow Studio. It's all of that orchestration that's done visually and simply for you. The Workflow Studio allows you to focus on your business logic, not writing configuration code or workflow definitions. It reduces the time to build your first workflow, so it's really good for developers who are brand new to step functions because it's going to reduce the time that it takes you to build your workflow with this new visual tool. And it's good for developers who are experienced with building workflows with step functions because it's just going to make it faster. Like you don't have to go through all the steps from how it was before. You can just do it visually. Also, there's going to be a demo of this in the leadership session that's happening later today, the serverless leadership session. I'm not going to tell you who's doing the demo, but there will be a demo. So you can drag and drop different actions from the left panel, put them into your workflow. And then you can monitor this all from the step functions console. Another thing that's really great with this is that there's a built-in integration with IAM. So for those of you who have had to deal with permissions and policies and IAM in step functions, or in AWS, sometimes you don't know which permissions you need, but there's an IAM integration with step functions that makes this a lot easier. It'll tell you which permissions you need based on the actions you've added. So cherry on top of that cake. With the Workflow Studio comes the AWS SDK integration. So Step Functions has added support for over 200 AWS services and more than 9,000 APIs. So until this launch, if you wanted to use a service that the integration didn't support, you would have to hard code it in your Lambda function, and that just made everything more complex, and it added a ton of cost. But now, with these 200 AWS services and 9,000 APIs, you can integrate your state machines with virtually any serverless service and other services that aren't serverless. And it just makes it easier to orchestrate your workflow. All right, AWS Batch has added console support for visualizing your step functions workflows. For those of you who haven't used Batch, it's a cloud-native batch scheduler that you can use to run your batch jobs. So they added console support for visualizing your step functions workflows. Basically what we did is we brought together 2 core AWS services to streamline management of your workflows. And this is great because batch jobs usually aren't just a single step, right? They're usually a ton of steps put together. And you can use step functions for that orchestration of all of those steps. Again, another way we're making serverless development easier. All right, next up is Amazon EventBridge. So EventBridge is a serverless event bus that makes it easier to build event-driven applications. So we touched on events a little earlier, but I want to go through an example of a successful event-driven application that is named after a river in Brazil that I'm guessing a couple of you have used before. So the main objective of this site is to get you to click on that place order button. Once you press that button, a bunch of things happen. So first we check your credit card to make sure you can pay. Then we have to go get the merchandise off the shelves and onto the trucks, and so on and so on and so on. This all happens in an Amazon warehouse. There's no synchronous API call for the Amazon backend to go package and ship products. What the front end does after your payment is confirmed is it puts together an event. And this event has all of your order information, it has your credit card number, it has what you bought, and it puts that all into a packaged event, and then it puts it into the cloud and onto a queue. Later, another piece of software will pull it off the queue and start the packaging, shipping, and all of that. So the key point of this process is that everything that I just said can happen at different rates. And normally, the rate at which people click place order and the rate at which the warehouses can get the boxes out of the door is relatively the same, relatively low. But on days like Black Friday and Prime Day, people hit that button immensely faster, right? There's so many more orders. And they hit that button immensely faster than the warehouses can operate. And that's okay because the backend will work itself through. So this is clear event-driven architecture. For those of you new to event-driven architecture, it's a relatively new space. And I think most people, when they think of building their application, they don't automatically think of using event-driven architecture. They think of using APIs, right? So let's just talk about the difference between APIs and events, because I think this will help you understand once we get into talking about EventBridge. So API thinking is synchronous thinking, right? You can't move on until the API response comes back. With APIs, you're sending commands, right? You're saying, go do this thing. It has an intent to the target. So create this account, add this product to the shopping cart, go do this thing. An event is something that happened. Maybe a new file has been created. Maybe an exception occurred or an error occurred. Maybe a new customer has been created or a new order has been inputted into the system. It tells you a fact, and they happened in the past. They are immutable, which means they can't be changed. So once it happens, it happens. So in practice, all it is it's a JSON, and it's packaged with everything that happened. A lot of people think events are like this super complicated thing that only specific people can build, but like if you can write JSON, you can write an event. So in the simplest terms, an event is a signal that a system's state has changed. It's a JSON. They are attributes. The attributes are that they are a fact. They are immutable. So once it's done, it's done. You can't unring the bell. So for example, if a customer places an order and then cancels it, that's two separate events. It doesn't undo the first event. It's observable, so anybody who's authorized can watch the event. So think of a coffee shop, right? If someone walks into a coffee shop and orders an espresso, then the barista is going to say, okay, I'm on it. But the pastry guy is going to sit there and say, like, I don't care, it's not a pastry. But if someone comes in and orders a chocolate croissant, then the pastry guy will say, okay, I'm on it, I'm going to make the croissant. And the barista will say, I don't care. They are observable, so only the people who are authorized, like the barista and the pastry guy, can view events. And they are temporal, so all events have a timestamp. All right, the first thing we'll talk about with EventBridge is cross-region event routing. All right, so using EventBridge, you can now route events from any AWS region to another supported region. The benefits of this is that you can centralize your AWS events, you can invoke asynchronous workflows, and you can replicate events to different regions. Basically, we're just making it easier to develop multi-region workloads. EventBridge also just launched support for sharing events between event buses in the same account and region. All right, so previously you couldn't go from bus to bus in the same region or account, but with the new feature, you can route events to buses in the same region. So this gives you so much more flexibility in routing your events, and it can be useful for keeping events in similar workloads on their own event buses. And I think this one's a little bit confusing, so I wanted to show an example. So let's say you have an enterprise company where you have 3 different buses, marketing, legal, and developer. In this case, all of your events could come in to the default bus, and then you could route events from the default bus to each of the departmental buses, depending on what they need access to or what they have to do. This makes serverless development easier because you can share events between event buses in the same account or region. Step Functions has an integration, a new integration with EventBridge. So now you can send custom events from your Step Functions workflows to an event bus without writing custom code. So basically, when we're doing this decoupling of orchestration logic, that's the benefit here, right? So it replaces the need for your Lambda functions to call EventBridge APIs. It can all just happen in Step Functions. Another way we're making serverless development easier. All right, the last service we're going to talk about today is the Serverless Application Model, or SAM. All right, so many times when people start developing serverless applications, they start in the console, right? So you choose the services you want and you connect them. So you choose to build a Lambda function and you choose your trigger here, you choose your destination here, it's going to talk to this other Lambda function, and you kind of connect everything in the console. You create everything, all the resources you want in this great UI, and this is a really great way to learn, right? It's a really visual experience. The only problem comes when you want to move your resources to other accounts, to other environments, right, to other places. chances are you're not going to know the exact configuration or the exact way that you did that in the console, right? So you're not going to know the configurations you set. To solve this problem, we're going to look outside of the console to something called templates. Templates, did you guys hear that music? Is it just me? Okay. Templates are a way to store your infrastructure as code so that it can be reusable. So with infrastructure as code, you're automating the provisioning process. So you're not going to go to the console, choose this Lambda function, choose this as the trigger for that function, connect them like this. You're not going to the console at all. You're going to use a tool called SAM, which we're going to use in a minute to deploy. You're also going to instantiate infrastructure using configuration files. So basically, this means you have this template, and I'm going to show you what a template looks like in a minute. And all of the steps and all of the configuration are included in that template. And it allows you to treat that configuration as code. And what do you do with code? You version it, you put it in some kind of repo in GitHub, you update it, you can deploy a new version and work on it, and then merge it if you want to update it. You can also roll back if you need to. So when you move to infrastructure as code, you do the same thing with your infrastructure. And finally, this allows you to eliminate configuration drift through automation. This was like my favorite thing when I was a test engineer, when developers would tell me, well, no, it works on my machine. So let's say you get paged one night because there's an incident for your mobile application, and you look at the logs, you figure out what's going on, and you realize that the problem is that you have to update a specific configuration in production. So you make the change in production, and you go back to sleep. Although you fixed the issue, you've just created an even bigger divide between your staging and production environments because you didn't make the same change in staging. So many times, staging environments are not the same as production environments due to configuration drift, due to changes made during incident management. With IAC, rather than having this drift in environments, you have one central authority that is this SAM template, and you push your infrastructure changes through. We have a few IAC solutions at AWS. The primary one is CloudFormation. A lot of the other ones are built on top of CloudFormation. SAM is what we're going to talk about today. You can also use the CDK, which just lets you write a little bit more code. So you have a lot of options here. All right, so SAM is an open source framework for developing serverless applications, and it provides shorthand syntax for your functions and for your event source mappings and your databases. So just like React is a framework for building JavaScript applications, SAM is a framework for building serverless applications. Also, this is Sam the squirrel. He's the SAM mascot. I also just learned that the Containers group just created a mascot, and it's an otter called Pancakes. That's all I'm going to say about that. So SAM comes in two parts. The first is our SAM templates, which just lets you version your infrastructure as code. Then you have the SAM CLI, or the command line interface. This is a utility that you install on your local machine that helps you with local development, debugging, builds, deployments, all of the fun stuff for your serverless application. This is what an example SAM template looks like. It's written in YAML, and you can see there's a few resources we have here. We have a Lambda function, your IAM role, your API gateway API, and a DynamoDB table. You can also change the policies here, like here it says DynamoDB read policy. You can change your policies up. You can do that right from your SAM template. You can see the event source here for your Lambda function here is this HTTP API. So you can configure these templates to add any AWS resources you want and create your application. So this just gives you a ton of flexibility. So with these 20 lines of code, this on the left turns into this on the right. So You have a Lambda function that's triggered by API gateway. You have the DynamoDB table that stores the data. What's already created for you is the permission for API gateway to invoke the function. So SAM automatically gives you that permission. And then you have the policy saying you can only read from the table. All right, our newest launch for SAM is SAM Accelerate. The big idea with SAM Accelerate is that it makes testing your application so much easier because you're actually testing in the cloud. There will be a demo of this in the leadership session too. Not going to tell you who's going to do it, but there will be a demo. With SAM Accelerate, you don't have to emulate your application. You don't have to emulate your infrastructure. You just test in the cloud. There's 3 new features of SAM Accelerate we're going to talk about today: incremental builds, SAM Sync, and aggregated feedback. So to understand SAM Sync and incremental builds, we need to differentiate between code and configuration. So code is defined as anything in your Lambda function, your Lambda layers code, your OpenAPI specifications file, and your step functions Amazon States language file. Everything else is considered configuration. Incremental build is an update to SAM build. So SAM build, what it does when you run SAM build is it prepares the artifact that's going to be deployed. It makes sure all of your dependencies are in place, and it ensures you only have what you need. So before, when you ran SAM build, it used to be that it builds everything all the time. I don't care if you changed just your code. I don't care if you changed just your dependencies. I'm going to build everything for you all the time. So it'll get all the dependencies for you and all the code and package it up. Now with incremental build, unless you're changing your dependencies, only the code itself is going to be built out. And we did this because we realized that you all don't change your dependencies that often, so there's no need to grab them every time you do your build. So think of a Lambda function. You have this hello world Lambda function, and it probably has a few different dependencies. So if you change something in your Lambda function code, let's say you change the message, when you run SAM build, it's only going to update that code. So it's going to separate the cache, and it's going to keep the dependencies separate from the code itself. We also optimize this even further with SAM Sync. So currently, when you wanted to test your code in the cloud, what was that? Currently, when you wanted to test your code in the cloud, it would do a deploy and do a full stack update with CloudFormation. And it could take several minutes because it's going to deploy everything, not just what you updated. It would deploy all the dependencies, all of your code, all of your resources, all the time. Now, when you make a change and it's a code-only change, it doesn't deploy the full stack. It only deploys what you changed. This makes serverless development much, much faster because the whole stack doesn't redeploy. All right, so with SAM Accelerate, the last thing I'm going to touch on is aggregated feedback. So previously, you only received CloudWatch logs for your Lambda functions. Now, with aggregated feedback, you get logs for your Lambda functions, your API gateway APIs, and your step function state machines that are declared in your stack. And you can also get traces with AWS X-Ray here. So with SAM Accelerate, creating and testing your application is easier than ever. We created this new functionality to get away from the idea of emulating the cloud locally. So instead, we're giving you the tools necessary to actually test your features in the cloud. All right, next up for SAM is SAM Pipelines. SAM Pipelines is a new capability of the SAM CLI that lets you automatically generate deployment pipelines for your serverless applications. A deployment pipeline is just a sequence of steps that happen when you release a new version of an application. So what's great about SAM Pipelines is that with AWS, generally you have like multiple accounts, multiple region deployments, and SAM Pipelines supports that. We support CodePipeline, GitHub Actions, Jenkins, and GitLab, and we do have templates for all of these. SAM Pipelines is composed of 2 different commands. You have SAM Pipeline Bootstrap, which creates all of the environment resources, permissions. It does all the authentication for you. You also have SAM Pipeline Init, which is an initialization command that creates a pipeline file for your preferred CI/CD system. You can also combine the 2 commands with SAM Pipeline Init -- bootstrap, and it takes you through the entire guided bootstrap and initialization process. And lastly, for SAM, we have SAM Delete. SAM Delete just deletes your stack. It'll delete all of your zip artifacts from your S3 bucket, and it'll delete your container images that are associated with the stack. OK, next up, I want to introduce you all to Serverless Espresso. So basically, we're giving the developer advocate team for serverless is giving Starbucks a run for their money. We created our own espresso bar here at reInvent. It's located at the Dev Lounge at the Venetian, and I want to show you guys how it works. So there's multiple things going on here, and we used a few different services to make this application work. So the first thing you do is from your smartphone, you scan a QR code that takes you to a menu, and then you choose your drink, you customize it however you like, and then you receive confirmation once you place the order. Once you place an order from the ordering app, the order hits an API for the order manager service. Oops. Let's go back. All right. The API is going to invoke a Lambda function that's going to write your order to a DynamoDB table. That service is going to generate a new event that is going to say, hey, a new order has arrived, and that event is going to trigger a step functions workflow. The step functions workflow is just going to go through a bunch of validations. It's going to check, is the shop open? Are there people working there? Do we have everything we need to make coffee? There are 3, why does it keep skipping forward? There are 3 main apps on the front end that make this happen. We have the ordering app that you use to place your orders. You have the display app that shows you the queue of the drinks. And then you have the barista app, which is what the baristas use when they're making your drinks. And then you have your access layer, and this is how the front end talks to the back end. So when the front end makes a request, it uses the API. This is used to place new orders. It's used to get a list of the open orders. It's used to cancel orders, all of that functionality. The entire application is built with events. So EventBridge choreographs the events throughout the workload, and each of the services either produce or consume events. Those that produce events send those events to a custom event bus, and those that consume events use rules so that they only receive the events that they care about. This is a really important concept in event-driven applications. The producers and the consumers are totally decoupled. So think of my coffee shop example. The barista doesn't have to know about the pastry guy. They're just completely decoupled. And then step functions orchestrates the entire order processing workflow. This is where all of the validations are done. It checks, is the store open? Can I take new orders? Step functions also does timeouts. So you have 5 minutes to place the order from the time that you scan the QR code, and the barista has 15 minutes from the time that they receive the order to the time that they mark the order as ready. And these timeouts are built into the workflow. Then we have the publisher service that listens for a wide range of events. So new orders, canceled orders, completed orders. And it does this by defining rules on the EventBridge custom event bus. When it receives these events, it routes them back to the front end using IoT Core. And we use IoT Core because it's a WebSocket connection that enables your front ends to subscribe to updates. So we're not using polling here. We're just getting real-time updates. OK, something else we launched this year was the serverless patterns collection. And this is something that my team created, so I'm very proud of this. The serverless patterns collection is a repository of serverless examples that demonstrate how to use different AWS services together. So if you're new to serverless, or if you're not new to serverless, and you want to know, hey, how do I create a serverless application with API Gateway and DynamoDB and Lambda? You choose those services from the panel that I'm going to show you. And don't drop your clicker. And then you can choose the pattern right from the Serverless LAN website. I'm going to go through an example with you. It's a great educational resource for those of you who are getting started. It's also just going to make it faster for those of you who already know how to build serverless applications. All right, so what we're going to do is we're going to choose the services that we want. We're going to clone the repo. And then we're going to deploy the stack and test it. So in this demo, we're going to build a serverless application that invokes a Lambda function from changes to a DynamoDB table. So anytime an item is put into a DynamoDB table, I want to invoke the Lambda function and view the logs in CloudWatch Logs. All right, so you go to serverlesslan.com/patterns. On the left-hand side, you're going to filter by the services we want. So this is DynamoDB and Lambda. I'm going to click on the download text to copy the commands to the clipboard. Then in your terminal, you're going to paste the download instructions that you just copied. This is going to clone the repo and changes directories into the right place. Then you run sam deploy -- guided, and this deploys your application. You're going to get a set of questions, and if you keep the responses blank, then it's going to choose the default options. This is going to take a couple minutes, but you can see that our resources are being deployed. We're deploying a Lambda function, a DynamoDB table, and the necessary IAM roles for the DynamoDB table to access the Lambda function. So in my template, I set DynamoDB as the event source for the Lambda function. And then upon deployment, Sam says, hey, you need this role in order to give DynamoDB access to the Lambda service. So I'm going to go ahead and add that for you. I'm just going to give this another second. Is it frozen? I think it's frozen. No, it's not. It's just the lighting. All right, there it goes. So once it's done, you get this success message that your stack has been created. All right, so now let's test this thing. We've deployed our resources. So we're going to go to the DynamoDB console, choose tables, and then we're going to choose our newly created table that was just created for us. Once we're in the table, we're going to create an item. We're going to add an item to this table. We're going to name this something distinct. I don't remember what I named this. I think I did something funny. I added a name. What did I call it? Banana. OK, yep. All right, so we've added this item to the DynamoDB table. Now we're going to go to the Lambda console. From the Lambda console, we're going to view CloudWatch Logs. We're just going to make sure we see that that item was added to the DynamoDB table. Yeah, I know. Do you guys want to listen to that one too? I'll just open the curtain. All right, so we're going to view logs in CloudWatch. And we're looking for the banana item. And there it is. So anytime a new item is added to our DynamoDB table, this Lambda function is going to be invoked, and the logs, it's going to log that event to CloudWatch logs. So in just a few minutes, we deployed a SAM template complete with all of the resources that we needed for this application. We created the role for the event source mapping. That was actually already created for us. And then we tested in the console to make sure it works. And we did all of that in, 3 minutes? So if you don't know where to start with building your first serverless application, start with the patterns collection. So every quarter, my team publishes, and in case you missed it, blog post. We published this one just 2 months ago, and it includes all of the launches for our serverless services. You can scan this QR code to access the last one that we published. Okay, so we just covered so many new things, so much happening in AWS. If you haven't been paying attention at all for the past hour, I want you to take away 2 things. Serverless development is getting easier, and it's getting faster. And if you're like me, oh, is that applause for me? If you're like me and you can't get enough of serverless, head over to serverlessland.com, where there's more resources, blogs, videos, workshops, and learning paths to help you learn more about building serverless applications. This was a brief summary of just some of the things that we covered, or some of the things that were launched in AWS this year. Our teams are constantly releasing new features to make serverless development easier and faster. My name is Talia Nasi. I'm a senior developer advocate for AWS Serverless. Thank you so much for coming. Enjoy the rest of your reInvent.